Welcome to video number 2 of us discussing ellipses. What we did in video 1, just as a quick recap, we analyzed ellipses that had center of the origin. We also really went through the anatomy of what that ellipse looked like. And then we did do some solving of applied problems. For this video, we're just going to analyze what happens if we are not at the center H, or at the origin, we're at a random center H, K. I am going to reference this a little bit just to say, remember the H is really your horizontal distance away, and K is your vertical distance away. What that means is if we have a center of H comma K in our equations, rather than them saying x squared over a squared plus y squared over b squared equals 1, as evidenced right here, what you're going to see is x minus h squared and y minus k squared, which is what we're pretty familiar with anyway. So without further ado, well, I have this equation of my ellipse, and if you first notice, this is not going to be x minus h squared over a squared, y minus k squared over b squared equals 1. Now keep in mind, if you remember from the last video, a squared and b squared are sort of interchangeable. It's really, I like to call this our horizontal ellipse, so horizontal radius and our vertical radius. So our horizontal and vertical radius. Our goal is to get it in that form, which means that complete the square. We are going to be doing some complete the square. Now, how do we know what orientation this is? Let's do the math and find it. It's a big game. Let's go for it. So with completing the square, what we're going to do is we are going to bring our x values together. We are going to bring our y values together. That's a minus 8y. Equals, and we're going to have to get rid of the 4 on the left side, take it to the right side by saying negative 4. So if you remember, to complete the square, we are going to halve that 4 and square it. So half of 4 is 2. 2 squared is 4. Maybe I'll show this on another line just because we do need to do a little bit of extra manipulation with the y first. So x squared plus 4x, we are going to add 4. Now, what's going to happen here is we have to factor the coefficient out in front of the y squared. The x squared did not have a coefficient, which is great, but we do have to factor out the coefficient in front of the y. So negative 8 divided by 4 is negative 2. Now, what I have done by adding 4 here, I have to keep my equation balanced by adding 4 on the other side. And I'm going to change colors. Now, to complete the square, what is half of negative 2 squared? Half of negative 2 is negative 1. Negative 1 squared is 1. What do I add to both sides? I'm really not adding 1. This is the biggest misconception that students tend to have. It's not that I'm adding 1. I'm actually adding 4 times that 1. So I like to represent it by showing 4 times that 1. Now going back to the equation, written in its complete square or completed square format, x plus 2 squared plus 4 times y minus 1 squared equals negative 4 plus 4 plus 4 is another 4. So I will divide both sides by 4, kind of like what I did before, to get the equation x plus 2 squared over 4 plus, here the 4's are going to reduce, so I get y minus 1 squared over 1 equals 1. So what is my center? My center is always h comma k, and the h goes with the x. So that center would be negative 2 comma 1. And I actually have the center written down this time, so negative 2 comma 1. And everybody, I strongly encourage you to plot right away. Now I do know what this graph is going to look like, so what I'm going to do is I'm going to change my scale just so that I can show this a little bit more efficiently on the graph. Otherwise, it's kind of small. So now negative 2 comma 1 should be right here. That's my center. And I do like to give the variable names on here just to help represent. Now, as I look at this equation, what I am seeing is this 4 represents my horizontal radius. So if you remember from the last video, this is really 2 squared. So my horizontal radius goes out 2 units. And then my vertical radius, which I'm going to do in this color. So my vertical radius, this is really 1 squared. Hopefully you guys knew that. So my vertical radius is 1. Now, this is where we analyze, is this a vertical orientation or is it a horizontal orientation? And the answer is, it is a horizontal orientation. Because this is horizontal, A is underneath the X. So A is underneath the X. So A is 2 and B is 1. And we do have our vertices. So let's go ahead and name our vertices. Our vertices, I'm trying to match up the colors here. Our vertices are right here. So our vertices are going to be at 0, 2. That's actually 0, 1 and -4, 1. Now, if you notice, this is really -2 plus or minus a, comma, 1. So -2 plus h plus or minus a, comma, k, which is what we have in that chart that I showed you guys before. I'm not going to go back to it. I would prefer that you write it, since these are nice exact points, write it that way. So we are left to find our c value. And if you remember that c squared is going to equal a squared minus b squared. So c squared is 4 minus 1. C squared is 3. So c is the square root of 3, which is about 1.7. So if we go 1.7, so this is 1, 1.5, 1.7 is going to be right about here to get my foci. Now, if you notice, this is a very flat ellipse, and if you remember from the other video, that as our foci get closer and closer to our a value, or as c approaches a, we're going to have a flatter and flatter ellipse. So here we could write the c value as the square root of 3. And so our foci, this is where it's going to be very useful for us to utilize this center value. It's going to be -2 plus or minus the square root of 3, comma, 1. All right, problem number 9. And our last problem that we're going to graph and then analyze. So once again, we are in what we call the standard form of a conic section. Let's go ahead, bring our x's together. 2x squared minus 8x plus 3y squared plus 6y equals 1. Let's go ahead and factor out the 2, x squared minus 4x, factor out the 3, y squared plus 2y equals 1. And now to complete the square, let's do this in a different color, just represent. So half of -4 squared is 4. So I have to remember to add not just 4, but add 2 times 4 to this side. And again, different color. Half of 2 squared is 1, so completing the square. And to keep things balanced, I'm not just adding 1, I'm adding 3 times 1. So I have the equation 2 times x minus 2 squared plus 3 times y plus 1 squared equals 1 plus 8 plus 3. 1 plus 8 plus 3 is 12. So if I divide both sides by 12, I get the equation x minus 2 squared over 6 plus y plus 1 squared over 4 equals 1. So there's my equation in its standard form. I think I called this one standard form earlier. That's more the general form. My apologies. So I have this in the standard form of an ellipse. My center is h comma k. So my center is 2 comma -1. Our a value, the bigger number, is underneath the x. So since the bigger number is underneath the x, this is another horizontal ellipse. I kind of wish I would have done a vertical one, but horizontal ellipse. Our a value is going to be the square root of 6. Our b value is 2. So remember, that's a squared, that's b squared. And c squared is a squared minus b squared. So c squared is 6 minus 4, which is 2. So c is the square root of 2. Now all of this, and I haven't plotted anything, so sad. Let's go ahead and do that. So our a is 2 comma -1. And once again, I am going to extend this just so I could see it a little bit better, or I'm going to change my scale. So our center is 2 comma -1, which would be right here. The square root of 6. The square root of 6, I think we're going to have to be a little bit more precise on this one. So the square root of 6 is 2.45. So square root of 6 is about 2.45. So as I go horizontally, I'm going to go 1, 2.45 should be right about here based off of our scale. So here is one vertex, and we know it's a vertex because that's a bigger number. 1, 2, 2.45 right here. Here's my other vertex. So my vertices are going to be 2 plus or minus the square root of 6, comma, -1. And our foci are going to follow our C values. And so this, the square root of 2. Hopefully you guys know that the square root of 2 is about 1.4, 1.41. So if we go 1.41, that gives my foci here. And 1.41, here's another focus. And our co-vertices, they're officially or unofficially co-vertices, would be right here. Those are 2 units away because of B. Those are the nice points. So we have a graph that will look like this. Now, let me go ahead and say 2 plus or minus the square root of 2, comma, -1. So one of the things that I am going to ask is, and it's not fully on my notes, I talked about it in the previous video, what is the eccentricity? If you look at graphing or working with conic sections from a polar form, this is kind of emerging of our chapter 9 and chapter 8 in the algebra that we've done. If you look at graphing from a polar form, you can understand what the equation should look like based off of its eccentricity. So really the eccentricity is what defines all of this. And that eccentricity, once again, just right here, our eccentricity is always C over A, which is why for a parabola, the C and the A are the exact same value. If you remember, as we did our diagram of a parabola, our C and our A, this is really our A distance, this is our C distance, that would be to the directrix. That's why C and A are the same, and our eccentricity of a parabola is 1. So eccentricity is labeled as E, or sometimes ECC. So eccentricity of the parabola is 1. If you remember from the last video, if we have an ellipse, the eccentricity is less than 1, but it's also greater than 0. For a circle, it's 0, and for a hyperbola, which we're going to get into next time, is going to be bigger than 1. So what is the eccentricity of each one of these? So our eccentricity is going to be the square root of 3. Actually, let me go ahead and formalize it at the moment. C over A. So that'd be the square root of 3 over 2. And if you take the square root of 3 and divide by 2, once again, I don't have my calculator up this time, but the square root of 3 divided by 2 is 0.866. Oh, we should know that because that is one of those standard ratios. So on this problem, the eccentricity is going to be the square root of 2 over the square root of 6. So the square root of 2 divided by the square root of 6 is 0.577. So it's about 0.577. So if you'll notice, this ellipse is not quite as flat, which is why your eccentricity is closer to half. This eccentricity is much, much flatter, which is why your eccentricity is getting closer and closer to 1. And down to the final stretch, guys. Thank you for staying tuned this long. So what happens if we're given information? How do we find how do we find our equation? And why would we care about this? Real life situations, you're given all these different aspects plotted on a coordinate plane, and then we can analyze based off of the geometry. So let me go ahead and make our generic axes. If my center is at 2, -2, which is right about here, let's call that the center. If our focus is 4, -2, that tells me a couple different things. Number one, because our focus is lined up with our center, we know that this is going to be horizontal. And if it's horizontal, then A is underneath the X, or really A squared is under the X squared. So let me write that out as X something over plus Y squared over equals 1. And now our center of HK, x minus 2 squared and y plus 2 squared. Center to focus, if you remember center to focus, this distance is C. Unfortunately, that C kind of looks like the center. My apologies. Let's actually change colors then. So if we change colors, then I actually, unfortunately, lost that too. Okay, going back, we know that from center to focus is C, and then center to vertex, our vertex ends up being out here at 7, 2, -2. So this distance is A. So from vertex to center, that A should equal 5 because we're going from 2 to 7. And we said already from center to focus, that distance is 2. So A is 5, C is 2. What can we fill in? Since A is 5 and it's horizontal, that would be 5 squared. We don't know our B squared yet, so that's our goal. And if you remember, C squared would equal A squared minus B squared, or rewritten, B squared is A squared minus C squared. So 25 minus 4 does give me 21. So the equation of my ellipse is x minus 2 squared over 25 plus y plus 2 squared for 21 equals 1. And our last problem, let's go ahead and do that in blue. As before, let's draw some generic axes. Our center is at 1, 2, which let's call that there. Our vertex is at 1, 4, which looks like it would be right about there. So if that's my center, automatically I can say x minus 1 squared plus y minus 2 squared over equals 1. Now distance from center to vertex, we know that that distance is 2. And if that distance is 2, that means that that is A. And because this is a vertical orientation, this also tells me that A should go underneath the y. So this is y minus 2 squared over 2 squared. Now our goal is to find B. In this case, we have x minus 1 squared over b squared. How are we going to find that? Well, if we know that our graph, and let's do this, let me highlight this part. If it contains the point 2, 2, let's try to match up based off of our graph. If our center is at 1, 2, and it contains the point 2, 2, we know that these are perpendicular, so this must be what we consider a covertex. So we got very lucky, and this is our B value. In that case, our distance from 1, 2 to 2, 2 is 1. So we have x minus 1 squared over 1 plus y minus 2 squared over 4 equals 1. And there you have it. I hope these videos were very beneficial for you, and good luck with you. And if you have any questions, you know where to find me. I'm Peter Beck.